All right. So we're starting chapter 4, which is going to be on scatterplots, plots, and correlation. Okay? All right, so we're going to talk about a scatterplot. Okay? It's a visual representation to show the relationship between two variables. Okay? All right, so a couple things about it. Number one, we try to put the explanatory variable on the x-axis. Okay, now sometimes that's not as easy as it sounds. Gentry, welcome.
Hi. Hi.
We had a quiz today, and it was were you here on time? But I'll give you some points for being late. How's that?
Thank you.
Okay. All right. So, remember, well, I'm going to add a step here. It should be the first step in your analysis. Okay. Now, a lot of times people will forget that step. Okay, and you'll see why in a minute. Okay. Now, some things the idea is we're going to look for striking details. Sorry, I put details, I meant deviations. Deviations from the pattern. We're also going to, here, I'll call that A. B, we're going to say, is it a strong relationship? Okay, meaning are the dots close together? And C, is it positive or negative? Okay? All right, so let me just draw a little bit of a scatter plot here for you. Okay? So here's what we're looking, well, I'm going to draw a bunch of different scatter plots, okay? Now, normally you're going to put the explanatory variable here, and you're going to put the response variable here, okay? Now, so let's say, okay, and the idea here is you're looking for, I'm going to add it here, we hope for a straight line, okay? So the idea here is, this would be an example of negative correlation. You could draw a line through these dots that would match that pretty well. Does that make sense? Okay. So this would be an example of positive correlation. Okay. Now you may see something that looks like a curve. Okay. Do you see how that looks like? Sometimes we call that the banana. Okay, this is not a straight line. I mean, you could draw a straight line, but you can see that there's definitely a curve there, right? Okay. You could also get something that has no real pattern. Okay. This would be an example of what we would call a null plot. And if you get a null plot, that indicates that there's no correlation. Okay? And in fact, first step, maybe I will add on to here, first step in analysis before correlation and regression. If we have time today, we'll talk a little bit about regression. But we're definitely going to talk about correlation today. Okay? All right, so these are let me give you some examples here. I'm going to share my screen.
What's that word on A? Look for
Striking deviations from the pattern. Okay, and actually, since you asked that, let me give you a striking deviation as I just, okay? As we come back here, so let's say that you have a pattern that looks like this, but then you have a dot out there, okay? That's probably an outlier, okay? Now, a lot of times we would call, because the idea here is, well, this deals more with correlation. But correlation and scatterplots kind of go together, are easily influenced by outliers / influential points. Okay, so we're going to talk about outliers, we're going to talk about influential points. Okay? Now, most likely, the way I drew this would probably be an outlier. It would also be an influential point. Influential. Okay? And the idea here is, if I exclude that point, okay, you can probably see that I could draw a straight line through the pattern there, right? Okay? But with that point there, what's going to happen is it's going to drag the line towards it. Okay? So this would be an example of an outlier that is also an influential point. Okay? Now, here's another example. Okay? Turn my camera a little bit here. Now, this would also be an outlier. Well, I guess we didn't scare everybody away after that test. They're all just coming late. Okay? All right, so Keaton, you know we had an on-time quiz today? You failed. But I'll give you some points anyway, because I'm a nice guy.
Thanks.
Okay? All right, so in this case, you could call this an outlier, but do you see that this outlier is kind of in line with all the other ones? So, yes, it's an outlier, but it might not be an influential point. Okay? Now, let me give you an example of something. One of my other statistics classes I used to teach, they don't do this anymore. But one of the things they used to do was they would make students watch this 2-hour video called Super Croc. Okay? And it was all about crocodiles. Okay? It was pretty intense. It was a documentary. Okay? So here's what happened. They found a crocodile head in Africa, in the desert of Africa, which means that a long time ago it wasn't a desert, it was a swamp. Okay? All they found was the head. The head of this crocodile was 6 feet long. That's as long as me. Okay? That was just the head. Now, it's the only one that they have found, but they wanted to say, oh, I wonder how long this crocodile is. How long do you think that crocodile is? Okay? So here's how they figured it out. They said, okay, we've got this crocodile head. If the head length is proportional to the body length of other crocodiles, so they went and they measured a bunch of different crocodiles. And they came up with a line, and they said, okay, so if it follows that line, then we think we can use that line to predict So in this case, the explanatory variable would be the head length. And the response variable would be the body length. Okay? So the idea with correlation is it can be used for prediction. And so what they did was they said, okay, clearly this is an outlier. We hope, there's no other specimens to compare, but we hope that it has the same, we hope that it's not just all head and no body. But, because it could be, I mean, right? It would be weird looking, but it could be. Okay, but if it follows all these other crocodiles, and they went and they measured a bunch of different crocodiles, then how long do you think this crocodile would be? 30? Any other guesses? It's a good guess, but it's too short. 40 feet long. No. That's what they actually made a model of what they think this crocodile would, and it was like, it took up the whole room. Like, you know, it was freaking amazing. And they were like, are you sure? And they're like, that's what the calculations say. 40 feet long. It was unbelievable. So anyway, so this would be an example of an outlier. Clearly that was an outlier compared to modern crocodiles, but it's not necessarily an influential point. So your influential point could be on either side. You know, I mean, it could be in the negative direction too. It could be on the top side, let's say. And so the problem is this would definitely be an influential point. Influential. Okay, because it's going to pull the line towards it instead of going through here. Okay, and so that's why it's so important when you're doing correlation. Okay, which is what we're going to talk about next. We're going to start focusing on correlation here. Okay, but you should never do correlation without first looking at your scatter plot. Okay, so let me give you some examples here. And maybe, hopefully, we won't watch any crocodile videos, but hopefully we'll watch some videos today. So here's what I want to do. Oh, I need to share my screen. I didn't share it. Oh, I hate this thing. Share. Okay. So the first website we're going to go to is Analytic Tech. MB313 correlate.htm, except for that's supposed to be a slash. That's right. Okay. So here's the idea. The idea here is you hope that you've got a nice, the dots are close together. Okay. This would indicate strong correlation. When they get wider apart here, that would be weaker correlation, okay? So here's some examples here, okay? This would be an example of what we would probably call a null plot. Now, usually, especially if you have this many points, it's hard to get a correlation of 0. So usually when we have a correlation close to 0, correlation close to 0 can, but not always, indicate no correlation. Okay, it must be backed up by a scatter plot. Which is why I said the scatter plot is the first thing that you should do. Okay, so this would be a correlation of 0.03, which is very close to 0, and so you can see clearly there's no pattern going on here. As we go down here, and I'm going to write some numbers on the board here, but what we're going to do, 0 could indicate no correlation. Okay. If the absolute value is less than 0.3, we use the letter R for correlation coefficient. We're going to call that weak. If your R is between 0.3 and 0.7, we're going to call that moderate. And if your R is greater than 0.7, we're going to call that strong. Okay? Probably should have included that in my video, but I'll do that in a minute. Okay, all right, so as we look at this, so you can kind of see here that there's kind of a general upward trend. You could draw a line through here, but your correlation is pretty weak. It's about 0.28 in this example, okay? This would be stronger correlation, 0.48. We put this in the moderate range. Once again, you can see you could kind of draw a straight line in the positive direction. 0.72, this is getting stronger. 0.89, clearly, sometimes we refer to that as the hot dog. You're looking for the hot dog pattern, okay? So that would be pretty strong correlation in this case. 0.99, this is so strong, I would almost think you faked your data, okay? You're generally not gonna see that except in textbooks in real life, okay? But that's a really strong correlation, okay? Now, let me show you some other examples here. Wikipedia, believe it or not. I know some people don't like Wikipedia, but I like it for math especially. If you look up correlation, and yeah, that's the one, okay? So what I want to look at is I want to look at this, okay? Okay, so these are some examples here, okay? So a positive one, you can see here on this little row here, or these three here, positive one would indicate perfect correlation. Negative one would also indicate perfect correlation. Now, you know, when we're talking about positive, we're referring to the slope, but you can see that these all have different slopes, right? Okay? So in this case, these are all positively correlated. In these cases, these are all negatively correlated, okay? We would say they would be equally strong correlation. Now, a flat line, well, we'll see, you'll never see that, but it's kind of weird. All right, so on the top row, we've got perfectly correlated positive one, 0.8, that's a strong correlation. 0.4, you could say that's a moderate correlation. 0, and this is what kind of a plot?
No.
This is a null plot. So if you see a null plot and you get a correlation coefficient of 0, that would indicate no correlation. And then these are moderate, strong, and super strong in the negative direction, okay? So the positive and negative just refers to the general direction of the slope, but doesn't refer to the slope itself. Now, here's why you need to pay attention to your scatter plot. As we look at this bottom row, okay, this is almost a W, right? Okay, is that a straight line? No. Okay, the equation which I'm about to show you in a minute, always, when you're calculating this, always assumes that it's a straight line. And if you've got a scatter plot that's not a correlation, that's not a straight line, okay, this would not indicate that there's no correlation, but it would indicate it's non-linear correlation, okay? So in this case, we would probably do the correlation coefficient, or we would do the scatter plot and we would say, well, it would be inappropriate to figure out the correlation coefficient. Now, there are non-linear correlation coefficients, but we're not going to learn about them in our class. That make you feel a little better? Okay? All right, so this square diamond thing looks like fake to me. They're just trying to illustrate the point. This 0 here, this is a kind of a parabola. This is something you would see in real life, okay? So you might get a correlation coefficient of 0. If you don't look at the scatter plot, you may inappropriately claim that there's no correlation, but in fact there is. It's just not a straight line, okay? This could be two different populations, also 0 correlation. I've never seen anything like that in my life. I don't know why you'd see that, but in this case, you'd probably say you've got 4 different populations, okay? And so that's why I'm spending a lot of time on scatter plots. Now, let's do an example here. Well, before we do, let me just ask you a few questions. Although I'm gonna stop sharing so you can see what I wrote on the board over here, okay? All right, so do you think that your weight and your grade would be correlated? Doesn't make a lot of sense, right?
Pounds or weight of the grade?
The weight of yourself. Okay. All right. How about, do you think that that your shoe size would be correlated with how tall you are? Okay. Now the question is, as we're doing this, so a lot of you shook your heads and said yes, you think that might be correlated. Okay. So the question is, if you were to create a scatter plot of your shoe size and your height, okay, going back to here, which one would be the explanatory variable? And sometimes, by the way, there's not always a perfect answer to this, but do you think your shoe size would explain how tall you were, or would how tall you were explain your shoe size? Chicken and the egg thing, isn't it? Okay? So, in the book, they make a big deal about the explanatory. Okay? It's kind of like the crocodile I was telling you about. Does the head size explain how long the body is? Well, in that case, it did, because all they had was the head size. Okay? So in that case, we're going to put the head and we're going to put the body here. Okay? Now, in real life, well, so, and I'm not too picky on this, because to be honest, the correlation coefficient doesn't care whether you put your shoe size here and your height here, or you put your height here and your shoe size here. It does not. This Scatterplot doesn't really care. But as a general practice, you should usually put the explanatory variable, and some of them are a little bit easier. Okay? So let me give you another example. Let's say I've got two variables, is time spent exercising and your weight. Do you think those might be correlated? Probably. Probably. Okay, so now the question is, we think they're related. Okay, which one is the explanatory? Does the time you spend exercising explain your weight, or does your weight explain the time you spend exercising?
Time.
The first one, right? So we said that the time we would spend exercising would be on the x-axis, and your weight would be on the y-axis. Okay? Now, if you were guessing, do you think this would be positively or negatively correlated? So think about it this way. Negative. People who spend more time exercising, do they weigh more or less?
Less.
Okay. So you said negative. So we would probably expect, if it's linearly correlated, we would expect a negative correlation. So if I've got, if this is 100 pounds and this is 200 pounds, and this is 10 minutes and this is 100 minutes or something, okay? Now, by the way, notice this is in pounds, this is in minutes, okay? So you can compare two variables that aren't the same units. One of the things about correlation, R equals our correlation coefficient, okay? And it is unitless, okay? It doesn't care what your units are, okay? So you can measure, time in minutes and weight in pounds, and that's fine. They don't have to be the same unit at all, okay? Now, in the case of the crocodile, if we were doing this in centimeters or meters or inches or feet or whatever, you'd probably keep them the same. So let's say we did it in centimeters and we did it in centimeters. That would be fine, okay? So they can be the same unit, but they don't have to be. Does that make sense? All right. So, so let's say here. So, yeah. So now the moment that you've all been waiting for, the equation, right? That's what you all wanted to do. You're like, we haven't learned any math today. What's wrong? Okay. Keep.
So would the explanatory, would that just be like what's formed in the equation or the question? Is that if it's harder?
No, when I'm talking about explanatory response, I'm talking about the scatterplot.
I mean, like, if it was hard to choose, when you look at the equation and ask what that says, like.
No, the equation's not going to help you at all.
So does your shoe size affect your height? Would you put that. Your shoe size.
So here's the deal. Let's say we did shoe size and height, and let's pretend it looked like this. Okay? If I were to draw shoe size, whoops, shoe size and height, okay? So rather than be this, it might be more slanted. Okay, so you can see that the slope is different, but your R doesn't care. Your R is going to be exactly the same. Whether you put height on the x-axis or on the y-axis, R doesn't care. It can't see the graph. Okay? All right, so here's the equation for the correlation coefficient. R equals 1 over n minus 1 times, yeah, we can see that. What does that mean? The sum of xi minus x bar over s sub x times yi minus y bar over s sub y. Okay? Now, I will give you that equation on your formula sheet. In fact, it was probably on the last test. You probably just ignored it and said, I don't care what that is, right? You're going to care this time. Okay? Now, some of you like steps to follow, right? Okay? So here's what I'm going to do. Here's your steps. Okay? I will give you this formula, but you have to memorize the steps if you want to memorize them. Okay? All right, what does x bar mean? Do you guys remember? Find the mean. So we're going to find the mean for your x and your y. Okay? Number 2, what do you think s sub x and s sub y stands for? Standard deviation. Find the standard deviation of x and y. Okay? Now that you've been tested and you all passed with flying colors, right?
When the test is open, yeah.
I'll let you use the stdev command from now on.
Really?
Yeah. You couldn't use it on the last test. You could, but you'd get 0 points. Okay? You could check your answer and it would have been okay. Did anybody check their answer? Did you get it right? Oh, good. Okay. All right, you can use that command from now on. Okay? Now, let me ask you a question. Does that look like any formulas you've seen before, what I just underlined?
Yeah, the z-score.
The z-score. Okay? That's exactly what it is. Find the z-scores for x and y. Okay? What are we doing with our z-scores? We're going to multiply them. Find the product of your z's. Okay? This is all order of operations. What's this telling me to do? Add them up. Find the sum of, what am I finding the sum of?
Product.
The products. Number 6, divide by n minus 1 pairs. Okay? All right, so we're going to do a real life example here. And you guys are going to be my subjects. Do you consent? Okay? It's not going to hurt, I promise. Okay? All right, we're going to do this example where I want to see if there's a correlation between your shoe size and your height. Okay? Now, like I said, it doesn't really matter. I'm going to call shoe size the explanatory, but I could call height the explanatory. Okay? All right, so now we're going to share our screen. Okay? And if you want to follow along, only Eddie can, it looks like. Okay? All right, so here's what we're going to do. Brock, Do you mind telling me your shoe size? 10.5? How tall are you? 5, 8.5. So 5 times 12 is 60. So you're 68.5 inches tall. Okay? Billy, what's your shoe size? 9. And how tall are you?
We're talking about like inches?
Just tell me how tall you are.
5'4".
5'4". So you're 64 inches tall. Okay? So we're doing shoe size and shoe size. We're doing height in inches. Okay, so now, Cray, how tall, what's your shoe size? 10 and 5'10", 5 times 12, 60, so you're 70 inches tall. JC?
My shoe size is 6.5.
6.5.
And I'm 5'8".
5 times 12, 68 inches tall. Olivia? Oh, does it matter? What do you think?
Yeah.
Okay, so here's an interesting thing. It probably does. We have a very small group here, and we would notice on the scatter plot that we might have a set of men dots together and a set of female dots together. Okay? I'm going to ignore that for now, but we're going to check our scatter plot and see. Okay? So we're taking your girl size, that's fine. But in real life, we probably should be more concerned than I'm going to be concerned today. Okay? You are size 7. So you're 64 inches tall. Gentry. And you're 65 inches tall. Keaton.
9.5. 10.5. Sorry, 5.5. 5 feet 10.
5 feet 10 inches tall.
So
you're 70 inches tall. Okay. All right. Why am I having a hard time with your name? Jordan.
Yeah. Size 11.
11.
And 6'3".
6 times 12 is 72, 75 inches tall. And Robert.
Size 9.
Size 9.
And 5'2".
5'2", so you're 62.5. Well, you might be the outlier. All right, let's see. All right, so what's the first step we should do? Nope.
Oh. I wrote this down.
You did write it down, and I knew you'd all forget. I erased it too. It was right there in green. What did that say? What did you say?
Try to put the exponent for the on x-axis.
Okay.
No.
Well,
wasn't right.
I wrote that first, but there was something that then I said, oh, I should have said this first.
The first step in it. But what is it?
Create a scatter plot. See, you already forgot. Okay? So create a scatter plot. So how do you think you would do such a thing, right? Highlight your data. Insert. And that one right here looks like a bunch of dots. That's your scatter plot. You're just going to pick, oh, the first one. Why is it doing that to me? Okay. What do you think of that graph? Is it a good graph or a bad graph?
The axis.
We don't have any axis titles, right? It's a bad graph because it's not labeled. Okay. So how do I put axis titles on it?
Right.
Click on the green plus sign. Add some axis titles. What goes down here?
Shoe size.
This is our shoe size. Okay. What goes over here? Height in inches. Okay. What do we want to call this? What'd you say? How about math 1040 class? Okay. All right. So we've just did a sample. So we look at this. Okay. We haven't done any calculations. Number one, do you think linear correlation would be a good idea? Sure. Why? Not really curvy, is it?
Not very curvy.
It's not very straight liney either. Okay, but you could maybe draw a straight line through it. So we haven't done any calculations. If you were to look at this, would you guess that this was moderate, strong, weak, or no correlation?
Moderate.
Weak, moderate.
You ignore those two right there. It's pretty.
If you took, yeah, I think Keaton, or no, that was Jordan. Jordan might be the outlier there. We might want to do our 5-number summary and look for that. Okay, I'm going to skip that because I want to go get through this. But yeah, that might be something to see. If we took Jordan out of here, we might say there's no correlation, right? Okay, Jordan might be the influential observation here. Even if he's not an outlier, should we see? Check that for outliers. Okay. All right. Now, do you guys remember how to make a box and whisker? In fact, here's what, well, would it be a good idea to put these on the same graph? No, because the units are not the same, right? It's okay to put them on here together, but I probably, if I were going to do a box and whisker, let's just do that super quick. Box and whisker, so this would be shoe size. And it doesn't, looks like we don't, so this is the quick and easy way to see if you have any outliers. We're going to find out if George is an outlier right now. Insert this one here. Okay, he didn't show up as an outlier. Okay. So even if he's not an outlier, I would still say he could be an influential point. Okay? Because not only is he the tallest guy in the class, but he's got the biggest foot. Okay? But it doesn't look, as far as shoe size, he doesn't look like an outlier. Maybe a little bit on height, but our scatter plot, he didn't show up as an outlier. So he's okay. He's not crocodile head. Okay? All right. So let's now that we've done this, so we've done all these nice little graphs here. This is something, if we do, I haven't decided if I'm going to do a project, but this is the kind of thing that you should think about if we did a project, okay? All right, so now we're going to do the correlation coefficient, okay? So step one, here, before we do that, let me see if I can find correlation coefficient. Hopefully it's in here. There it is. Well, that's a different looking formula than I wrote, but it's basically, yeah, it's basically the same as that. Can I copy that image? Oh. Copy image, paste. It won't paste, never mind. Okay, so step one was what again, JC? Find the mean of X and Y, okay? So how do you find the mean, Robert?
You basically find average.
And did you curse Bill Gates when you said that word? Use the A word. Okay, so Brock, how do you do this? What's the next step? Find the standard deviation of X and Y. I probably should move this. Okay, all right, do you remember how to find the standard deviation? What he said. ST what? You didn't memorize that for the test yesterday? Here, I'm going to put a D. Is it a sample or is it a population? Was everybody here today?
No.
It's certainly not the population. So it's got to be a sample. Yeah. Most of the time when you're doing this, oops, I spelled it wrong. STDEV, you're probably going to use the sample. Okay? because most of the time we're going to deal with samples. We're not going to deal with populations. Okay? So the mean shoe size is 8.8 and the standard deviation is 1.6. The mean height is 67 inches, which is about 5'7.5". Standard deviation is almost 4 inches. Okay?
What does that number mean next to it? The one and then
What number mean?
the 3.9645.
That's what I just said. So the average height, I used the A word, didn't I? The average height of people in this class is 67.5 inches, which is about 5'7".
Okay, but you did it without like highlighting it. So.
No, I highlighted it. I just did it so fast it went right past you.
Okay.
See, there's your formula there. Here's your formula here.
You just did the formula on the left side and then copied it over to the right side.
Right.
So you didn't have to do it again.
Right. Oh, is that what happened? You didn't get that? Okay. All right, I just copied the formula here and put it here. Okay? Does that make sense?
Yes.
Okay. Step number 3 is what? Eddie?
Find the z-score for x and y.
Z for the X and the Y. Now, here's what the common mistake people do is they often forget stuff, okay? So we're going to do the Z-score for the shoe, and we're going to do the Z-score for the height, okay? So, Eddie, what should I type?
Z-score.
So, Z-score. So the Z-score is X sub I.
Yeah.
What's X sub I in this case?
X sub I would be the data of shoe.
So the first person's shoe size, I think this is Brock's shoe size in this case, is 10.5 minus the mean, which is 8.83. And just hit that. No, there's more to my formula.
Oh, is it? Oh, great.
Divided by
standard deviation,
which is
1.63.
1.63. Is that the correct? Sort of.
Do you want to do F4?
Don't I want to do F4? Don't I want to do parentheses? Both good questions. Do I want to do F4 and or parentheses? Let's do the F4 first. Do I want to do an F4? Yes. Where?
On A12
And
A12 and A13. I want those both there. So if I go back here, I press F4. Okay. I want the mean and the standard deviation not to change. I want the data to change when I copy this formula. Okay. Is there anything else? Now you mentioned parentheses, Keaton.
Yeah.
Where's the parentheses go?
Around A2 and A12.
A2, so the numerator, A2 and A12. So I need to close my parenthesis there. I need to put it in here, okay? All right, 2 of the most common mistakes. I'm glad you guys stopped Eddie. We were scared, okay? All right, so, well done, okay? Now, let me just mention here, make the mistake on purpose here. I'm going to take this out. The answer was 1.0 something. Okay? Now it's 5.1. Okay? It's the wrong answer. Okay? So make sure you put your stuff back in here. Let's do it for the height. Gentry, it must be your turn. What's my Z-score for my height?
you start with
68.5
minus
10.5? No.
what do you subtract?
Because look at your formula here. It's y sub I minus y bar. What's y bar?
The mean?
Which mean?
67.4.
67.4. That's better. Okay.
Divided by
Divided by,
standard deviation.
which is
3.9.
3.9. Okay. Is that correct? Yeah. So you could have done that at the beginning. So let's put the F4 there, the F4 here, put the parentheses in the numerator. Okay. Now it's correct. Okay. Now I'm going to copy and paste those. I'm going to just watch this really slick thing. If I put it there, it's the black cross. Double click. Ooh, nice. Okay. All right, slick.
Like,
Jordan,
copy the left one and paste it somewhere.
can you copy this one over to here?
Yeah,
No, you can't, because it's always, if you did, in fact, watch this. Watch what happens when I do. The answer should be 0.266. Now it's 36. It's way off. Because in this case, I'm taking the height minus the shoe mean. I don't want to do that. Okay?
I thought that was what you're saying you're doing.
Yeah.
You just highlight.
You just highlighted.
I highlighted the top two cells and then copied them down.
So you can also copy sideways.
You can. When we copied sideways, we got the wrong answer, though.
Yeah, but that's what you did for the mean. And
That's
it's
what I did for the
all
mean.
of the
For the mean, it
heights.
was okay. Yes, that was okay.
How did it know to do it, though? Okay, never mind.
'Cause of the
I'll
relative
just accept
references.
that it does it, and I don't worry about
Well,
it.
you do need to understand that. In this case, look, I've got relative references. So when I changed it from column A to column B, it changed the column
It
for me.
just knows. Okay.
But if I put the dollar signs in there, now notice that only the first number changes. The rest of it doesn't change. Okay, so you need to know what you're doing or you'll get it wrong. Okay? All right, step number 4 is what, Jordan?
You multiply the x and the y.
Find the products. Okay? So we're going to do the products. And then we're going to get what?
Equals C2 times
C2 times D2. Okay? We're going to copy that down. Oh, should I have F4'd any of those?
No.
No. Okay? Keaton.
How do you do F4 on laptops?
So here's the deal. I know that Jordan's got a Mac. Instead of F4, it's Command T. Do you have a Mac too? Yeah. Oh, you got a Mac too. So you can use Command T on the Mac.
Well, I've got a Lenovo.
And you've got a Lenovo. And did you know that's a Chinese computer? I did not either, so I bought one. Anyway, not that there's anything wrong with Chinese, except for they spy on us with their phones. Have you heard about that? I was like, I don't know if I should buy stuff from them. They're spying on me.
Is that really a real thing?
Oh, yeah, the HTC phone, they spy on you. The government won't take any of their phones.
So like on Mac, am I going to be spied on?
Oh, I don't know. We haven't heard anything about
Big
Mac,
Brother's
because
always
Macs are made in China too, aren't they? But anyway, yeah. But Mac, at least Apple owns, they just make their stuff there. They don't own it, but a Chinese company owns Lenovo. Anyway, so you probably have an FN key on your thing. So if you press function F4, it should work.
Let's try that.
Let me see.
It's loading.
Okay, when you get ready, let me know. All right, so we found the products. What's the step number 5? Gentry, it must be your turn.
Again?
Oh, yeah, because we got a small class today.
Oh. Step 5 is find the sum.
And the sum of the products. So what am I supposed to add up?
The products column.
This products column. Now, I always leave a gap there. Did I tell you that? Always leave one. It'll save you from making a mistake. Okay? So that's the sum. Robert, what's the next step?
Then you divide by n minus 1.
N minus 1 pairs. Okay, so let me see here. So that's step 6.
Sorry, some of the products, I was looking down. Will you do that part again? What ones did you take?
That column right there.
Some of all of them.
Okay. And then we're going to divide by n minus 1. Okay. Now my question is my n 9 or 18? It's 9, right? It's the pairs. We've got 9 pairs going on here, right? So we're going to divide by, in this case, 8. 9 minus 1 is 8. Okay? Divided by 8. And I get 0.59. So we would say 0.59 is how strong of a correlation? Moderate. Okay? Yes.
Oh, doing the n minus 1 because it's a sample? Is that, I understand. You always do that.
It's always n minus 1. Generally, when you're doing this, it does come from a sample. And that's a good way to think of it. It's n minus 1 because it is a sample, and it will always be a sample. Okay? All right. Okay, so this is called the correlation coefficient. Okay.
When you do the find sum of the products, do you add both of them together?
Find the sum of the products,
Oh, you just add all those together.
add that column up.
And
Okay.
that is the two numbers.
That's these two numbers multiplied together.
That, okay.
Yeah. So let me ask you a question. What if I got an answer of 1.2? Not right. It's clearly not right because it can't be greater than 1. What if I got an answer of negative 0.56? Is that possible? Yeah, that's possible. Okay. What if I got an answer of 0? That's possible. Okay. All right. But the real answer is 0.59. Okay. All right. So now, have you all heard the phrase correlation is not causality?
It's not what?
Causality?
I don't know what that means.
You don't even know what that means. Okay. So correlation does not mean, so doesn't mean that your shoe size causes you to be tall or short. No, but there is some sort of a correlation going on. Okay. Now, one of my favorite websites here, we're going to pull up a really cool website that talks about what we call spurious correlations. So, tylervegan.com/spurious correlations. Okay, now by the way, well, I'll show you here in a second. Okay, now here's the deal. He's not necessarily doing straight line correlations, but here's what it says. Okay, U.S. spending on science, does that cause suicides by hanging, strangulation, and suffocation? The more you spend on science, people just want to hang themselves, right? How many of you agree with that? Doesn't it make you feel that way? You guys are all science fans here, right? Biased. Okay. So do you think spending causes people to hang themselves? Only college students, right? Okay. How about this one? Do you see that the number of people who drown by falling into a pool seriously must be caused by films Nicolas Cage appeared in? Right? I watched a Nicolas Cage film, it just made me want to drown. Right?
I can relate.
Okay?
That's true.
But you can see that looks highly correlated, doesn't it? There's got to be some sort of relationship there. How about this one? Per capita cheese consumption and number of people who died becoming entangled in their bed sheets. Strong correlation, right? Don't eat cheese, you're going to die in your sheets. Right? Okay? Correlation does not imply causality. How about this one? The divorce rate in Maine and the per capita consumption of margarine. Save your marriage, don't eat margarine. Okay? Isn't that what that graph says? Okay? So once again, these are some great examples. Oh, this is a great one. The age of Miss America correlates with murders by steam, hot vapors, and hot objects. Very nonlinear correlation, but clearly we like younger women to save us from dying from hot vapors. Right? Okay? All right. So these are some fun little graphs here. But the idea here is just because there is a relationship does not mean that one variable causes the other. Okay? Now, in order to establish causation, you need other things. Why is that not in my notes here? I'm gonna have to add that to my notes. But let me show you some other things, okay? In fact, I got some great YouTube videos here. I should make these favorites. Oh, I think, oh, actually, those. Okay, I'm going to show you this one here. Never mind, I'll just search for it. I don't know if here's what I'm going to do. I'm going to show you the link here, correlation versus causality, Freakonomics movie. It's this 1.5 minute one. I'm going to pause the video, or I'll stop the video because I don't want to get into the copyright violation for posting this on YouTube. But you should watch this. It's this first one here. Just put polio and ice cream. I think it's a really interesting video. And so for those of you who are watching at home, just do that search that I just did. Pick that one there. I'm not going to record this though. So how do I stop this recording? I wish there was a pause button. I'd rather just pause it than stop it, but I will stop it.